Going to discuss about the law of conservation of angular momentum. Firstly, let me revise one thing. What is angular momentum? Angular momentum is basically the product of the position vector and the linear momentum. That was the formula of the angular momentum, that is I into omega. That was the formula for the linear momentum. Now what the law of conservation of angular momentum states? It states that in the absence of torque, total angular momentum of the system is conserved. What does it mean? In the absence of torque, total angular momentum of the system will be conserved. For this, we have to firstly understand the relation between torque as well as angular momentum. Firstly, we have to discuss this. Now, as we know, what is the formula of the torque? That is I into alpha. Okay, that is moment of inertia and that is the angular acceleration. Now torque is equal to what it is equal to? It is equal to the change of velocity, angular velocity with respect to time. So we will be putting its formula here, that is I into change in velocity upon time. So what is the change in velocity is basically equal to Vf minus Vi. As we know that change is equal to final minus initial. So instead of this we will be writing Vf minus Vi divided by time. Now we will be multiplying it. Torque is equal to I into final angular velocity, then minus I into initial angular velocity divided by time. Now as I said, the angular momentum is equal to the moment of inertia into angular velocity. That is the same formula. So here we can write angular momentum as well, that is L. Now that is final, so we are writing it final, minus that is also equal to L, and it is initial, so we are writing it initial, that is also time. Now torque is equal to, that is equal to, as we know, that will be equal to change, because final minus, so the final minus initial will be equal to the change in angular momentum, that will be equal to change in angular momentum divided by time. Now what does it mean? That the rate of change of angular momentum with respect to time is called torque. The torque is equal to the rate of change of angular momentum with respect to time is called torque. Now this is the formula that we are going to use in torque, that is now torque. Now what was the statement? In the absence of torque, the total angular momentum of the system is conserved. Means the value of torque in the angular momentum will be like if the torque is absent, the angular momentum will be conserved. Now let's see how mathematically, let's prove that. If torque is 0, that is our condition. Now what we made a formula, that is torque is equal to change in angular momentum divided by time. The torque will be 0, change in angular momentum divided by time will multiply here, it will become also 0, so change in angular momentum will be equal to 0, means it will be also conserved. So as we know, change in angular momentum is equal to Lf minus Li, that will be equal to 0. So minus Li will move there, so it will be plus I, means final is equal to initial. So that is the law of conservation of mass. This is known as the law of conservation of angular momentum, that if the torque, in the absence of torque, the total angular momentum of the system will be conserved. Now like here LF is equal to Li. L, that is equal to I into omega. So it is final, we are writing it final. Now that is also I into omega, that is initial, we are writing it initial. So here what is the unit of that formula of that? It is mr square into final angular velocity, and I is mr square, that is again initial. Now what does it mean? What it is showing that if suppose if I increase the radius 3 times, so 3 times the angular velocity will decrease. If I decrease radius 3 times, the angular velocity will be increased. So here that will be a ratio, here that will be a ratio, that will be equal to 1, that will be equal to 1. So the ratio will be 1:1.